So we're in 4A. We'll do quiz scoring some other time or maybe at home. But the top question, I told you there was like 4 pairs of answers that they're separating these levels into sublevels. So what were the main sublevels, the 4 sublevels? There's a thing called S, P, D, and F. How many does an S sublevel fit? 2. The P's fit 6, the D's fit 10, and the F's fit 14. So if we go back to talk about the levels, how many electrons does the first level hold? 2. So that means out of these, it only has an S. The second level holds 8, which means it has an S and a P. The third level holds
28.
total of 28, including all 3 levels. So that's 18 new ones. So how do we get to 18? S, P, and D. Because if we add those up, that adds up to 18. Guess what happens on the 4th level? You have S, P, D, and F. There's all 4 sublevels. And if you add up that stuff, that adds up to 32 is correct. It stands to reason that the 5th level would have how many sublevels would you think? 5. And maybe it would, but they haven't discovered enough like elements to stretch the periodic table that far to even like tell you that. Okay, but in theory, not making, maybe it made the reading, maybe it didn't. Did it talk in the reading about a G? Did they mention G at all anywhere? Or we don't read it, we just skim for the answers? Okay, so in theory, there is a G. How many do you think it would hold? 18. In theory, there's an H that holds
22.
And in theory, there's an I that holds 26, because there is a 6th level that would have how many sublevels? 6. And there is a 7th level that in theory would hold 7 sublevels. But like I said, there just aren't enough electrons or aren't enough atoms on the periodic table to stretch it that far to even like know if that would happen. The other new question on this was that when we go to fill these, the lowest energy sublevels get filled first. So you're going to fill S's before you fill P's, before you fill D's, before you fill F's. You're going to fill level 1 before you fill level 2, before you fill level 3. And as I've been alluding to for several days, you start to sometimes have some electrons filling different levels. You have like maybe 2 or 3 incomplete levels at a time where there's vacancies in like 3 different places. You're going to fill the lowest energy ones first at a certain point. Question about that so far? So here's a diagram from the book that will make the next quiz, but the next quiz isn't tomorrow. Tomorrow is just going to be a homework talking day, I believe. Yes, that's true. So tomorrow's just homework talking day. I guess I should have probably left that up there. SOPD. Here's a diagram that's going to help you get this stuff filling in the right degree. So first level had how many sublevels? Just one, which was S. Second level, I'm going to do a little indent, so I would encourage you to jot this diagram into your notes. Second level has how many sublevels? It has 2, an S and a P. And then let's indent again. The third level has 3. The third level has S, P, and D. And I didn't leave myself enough horizontal space for this diagram, so I'm just going to erase some of this stuff and come up later. Fourth level, what's it have?
SBDF.
S, B, D, and F. Fifth level, S, P, D, and F. Sixth level, S, P, D, and F. Seventh level, S, P, D, and F. If you kind of do this like little indent thing all the way down, this is going to, when I complete this diagram in a second, it shows you the order in which these get filled. You come in here, you fill 1S, and you loop. And then you get to 2S, and you loop. And you go to 2P through 3S, and you loop. And here's where things start to get weird, okay? So up until now, level 1 gets filled before level 2 gets touched. Level 2 gets filled before level 3 gets touched. That's as far as we've gone. But what's happening at level 3 is you start to fill level 3, you take a detour to level 4, you fill a little bit of level 4 before you come back to 3 and fill some more. And then you're kind of simultaneously filling like 3, 4, and 5, doubling back to do some more with 4, 5, and 6, doubling back to do some work on 4, 5, 6, and 7, before you double back to work 5, 6, and 7, double back to 6 and 7, double back to 7. And in reality, if the periodic table went this far, here there should be a 5 S, P, D, F. Who was theoretical?
G.
There would be a 5G, like step in, but there's not enough electrons and not enough atoms for us to ever get to this little corner. But if we ever got to that little corner, we'd have to worry about maybe there being a thing called 5G. Then there's one other tidbit. These get circled. We rarely get that far. It rarely matters, but I'll explain what the circles mean when we get to a problem that matters for the circles, when we get like into this. Essentially, the circles are like line jumpers in Kennywood. Line jumping is cause removal from the park. Signs everywhere in Kennywood. Those are cutters. The 5D and the 6D, they like cut their turn a little bit here or there. Diagram, I don't know, I could try to explain it again, but the way to explain it is probably just to use it. I like to put some cheat numbers on my diagram, so on a test, maybe you want to put some of these like cheat numbers so we know how far we go before we even start. But if we fill the 1S, how many electrons would we be up to if that's filled? 2. Fill another S, we'd be up to 4. Fill a P and another S, and we'd be up to 12. Fill another P and another S, and we'd be up to...
So another P and another S?
Yeah, another P and another S. From 12, we're now up to 20. Another S, another P, and throw in a D.
38.
We're at 38. Another SP and D.
56.
Is 56. An S, a P, a D, and an F. We're up to 88, and then I wouldn't so much worry about it, but if you got to here, this would be a 118, and at the writing of our book, did we have 118 elements?
No.
No, so we're not too worried about like what's going to happen beyond 118 elements right now. But here's what they'll ask you to do. They'll say, hey, here's some elements. We want to write these using using these sublevels. The ones that I erased, I'm going to squeeze in on the other side because I have space over here. So it'll start off with like a little baby one. So how many electrons does this thing have? 1. Because this number counts, technically it counts the protons, but the protons and electrons are the same. So if we have 1 electron and we start to flow through this little diagram, the only place we would be is in 1s. And that has 1 electron. And we just wrote our first ever electron configuration in sublevels. It's an easy one. This has 2. So 1s gets 2. And that's as far as we need to flow because that 1s can hold 1 or 2. This has 3. So the 1s maxes out at 2. And then we forge ahead into 2s, which takes the other 1. And then we're going to throw a little comma to separate sublevels. And then I think they'll have you in the homework answer a follow-up question. How many valence electrons are there? What are the valence electrons?
The one's the highest one.
Highest level.
So there should be 1.
So this has
1.
1 because that was the highest level and it had 1. This has 2 because that's the highest level and it had 2. This
1.
has 1 because the stuff at energy level 1 doesn't count, only the ones at energy level 2 count. This number can never go higher than 8. Question about first 3 there? So slight growth over here. Everything's going to start with 1s and probably a 2 because that's going to fill. And then 2s and probably going to, on almost every problem, have 2 because it's almost always going to fill. Chances of us staying under 4 total is pretty low. Chances are on the whole periodic table we're usually going to get pretty deep. After 2s we're going to 2p. I don't do a comma to separate these because these are both at level 2. So we want to separate level 1 from level 2, but we don't separate level 2 from level 2. We're trying to do math here to add up to 5. So that's a 1. 2 plus 2 plus 1 that helped us add up to 5. How many of these are valence electrons?
3.
3. Because level 2, both of these are level 2, 2 plus 1 makes 3. Question so far? Yeah.
I mean, I guess it was kind of answered, but the sublevels don't count for valence electrons, only the actual level itself.
We go look for valence electrons, look for the levels. If there's a couple level 2s, look to both level 2 like exponent. They're not exponents, but they look like exponents. Look to the electron counts and put them together.
Okay, thank you.
So we're up to 7. So 1s2, 2s2, 2p. Can we fit them all in 2p? 3? Do they fit? P's fit 3?
Yeah.
Yeah, so we're good. 2 plus 2 plus 3, we're up to 7. Valence electron count is 5, because these are both level 2, we add them up. We're up to 10. So 10 starts off the same. 1s2, comma, 2s2, 2p.
2p6.
They can fit all 6?
Yep.
Yep, P's fit 6. Valence electron count
8.
is 8, and that's where we max out. If you ever got a number higher than 8, something is wrong. That's not an option. So we're up to 12. It's 1s2, 2s2. Can 2p go any higher than 6?
No.
No. So who's next?
3s2.
3s.
1.
And we need, how many more did we need?
2.
2. Valence count?
2.
Is 2, because we only care about the stuff on level 3. What minor mistake did I make on purpose?
No comma.
Where comma?
Between 2P and 3S.
When I upgraded from level 2 to level 3, we like to throw a comma. Question about those? Okay, we're going to need to do a small camera turn so we can see this, because I think we're off the video. What's going to happen to the beginnings of all of these?
1S2.
Yeah, 1S2, compared to the one we just did, it's going to all start off the
Same.
same. So I might as well just do that to get a little bit warmed up. 1S2, 2S2, 2P6, 3S. Is the 3S filled with 2?
Yeah.
Yep. So all of these. Gets kind of boring because you get to a certain point and you're going to write this beginning.
Could we use widow marks right at the beginning?
I mean, you could, I guess, at a certain point. But if we do these on a test, I'm going to want to see like the whole shebang. But if you had to do a lot of these that were deep, maybe you'd want to do that just to speed yourself up. But for 14, so if we look to the diagram, and the diagram's off camera now, oh well. But when we got to that curve, we were at 12, and now we're up to
EP2.
3P2, valence count, 4. Because the 2 plus the 2 from the level 3, we're up to 4. So these all have to involve 3P.
EP5.
This is 5, and I did this wrong. These should all be 6s. Is that it up? 10, 17, yeah, valence
7.
is 7. If I'm up to 19,
You have to go 3P6.
3P6 is now maxed out, so all of these are going to be 3P6s. And I got carried away with my commas there.
We need D1.
And then after 3P,
4S.
it's going to 4S.
Oh,
See how it flows?
yeah.
Like 3P is going to flow into 4S. And so we were up to 18 before.
1.
One more, valence,
1.
1. Anybody confused? 30.
4S.
So we would want to fill the 4S with the 2. Who's after 4S?
3D.
3D, so I'm going to do a comma. What's our math up to when we hit this?
2.
We're at total of
20.
20. 3D
10.
is 10, and it can hold all 10, and that's filled. I did another comma when I stepped from 4 down to 3. Valence count?
2.
2, because we only care about level
4.
4. Level 4 was the highest level. The fact we had some more level 3, nobody cared. Something there. 56. We go 4S2, 3D10. We know at that point we're up to 30. And that's why I put some of my cheat codes on here. We can see if we look at the cheat codes at the turns, 56 is going to land.
56 is landing at 6.
Is landing at like at 6S. We're going to fill everything as far as 6S. So if we look to that diagram, after 3D10, there's 4P fills with 6. There's 5S fills with 2. There's 4D
10.
fills with 10. There's 5P fills with 6, and 6S is a 2. What's our valence count?
2.
2. Question there. Here's where the circle comes in. The circle comes in with electron number 57. Okay, maybe turn me back if we're off screen here. So getting to here, we've accounted for the first 56 electrons. Electron number 57, based on everything I've said so far, you would expect to fall into
Or
4F. No. The circle cut in line will cut in line and steal 1. This will take the 57th electron. Through 56, we're here. The 57th electron will fall to 5D, and then 4F is going to take its usual next 14 turns. The F's usually take 14 turns. So we're going to get 1 turn for 5D cutting in line. F take 14 turns in a row before we go back to filling the D's, filling some P's, filling some S's. 88 electrons are handled up through here. Who would take the 89th electron? 6D. Then the F takes the next 14 in a row after that before D takes like its rightful turn in a sense. Chances of you using the circles? Pretty unlikely. Okay, but if we get up just above 56, just above 88, the D's cut in line and steal 1.
when the D's still 1 after the rest of the F's and stuff, do they have 10 still, or would they be down to 9?
Like the D will take 1, and then this might take 1, 2, 3, 4, 5, 6, up to 14 before the D takes its second one. So like if we have 50, let's do one more and see if that answers your question naturally. Okay, so when we try to get accounted up to 64, it's all of this same answer. And after the 6S2 actually is going to come 5D. Take 1. Then we're back to
6F,
4F. And our math, we were at 56 at the turnaround, so this got us to 57. To get to 64, this takes the other
8,
7. If there were 8, 9, 10, 11, 12, 13, 14 of those, they'd all go in the F. But if we get one more, now 5D's go into 2.
Oh, okay, so it goes back to D, you don't
It's
make
going
another
back,
5.
it's gonna fill, F will take 14 before D takes its rightful 10 again.
Okay.
Just 1 electron's worth cut in line. You with that?
Okay, yeah, that helps.
Okay. So valence count,
How many does 6 have 2?
6 had 2. Because it's just this determining the valence electrons, that was the only thing above us. Those answers get sort of long. But the beginning part of that is all the same. Like if I decided to do 65, you would need to just copy this whole thing and change that to 8. It's not that much different. That's a big board full of stuff. That's why I didn't think we had time to create the quiz. So homework, life off of this. See what's up. So there's a 3B you can do. There's a 16 and 17 doing this. There's not a read until we get to Thursday, so I think we talk about what's in the read tomorrow. We'll just talk about that and preview the read. But I don't really have anything else to say about this. Questions, stuff, anything, anybody?
You said 3B.
So 3B and 16, 17, and I'm sure 16, 17 is gonna have like A, B, C, D, E, F, G and
Yeah.
stuff. Yeah. So they go A to F like they usually do. Do they start off with some little ones?
Mm-hmm. Section 3.
What's the biggest number you see?
48.
48? Okay, so that's sort of nice because you never even got far enough to use the circle. 48's gonna like settle in there somewhere. I'm sure there's gonna be one on the test to test your knowledge of how to work a circle. Like, that if a teacher had this class, really, the authors who wrote that book, I don't feel like they did their job as authors to not test you in the cut in line thing. That seems wrong to me, but I'd have given you at least one that was above 56. But I didn't write a book, so who am I to criticize, I guess. Last call, questions? Made you work today. Thank you for your kindness, cameraman.